Okay, so we have this volume of rotation that's sometimes called Gabriel's horn. That's formed by taking this function, 1 over x. So let me just sketch this function. The function that looks something like this. Taking this function on the interval from 1 to infinity, and then rotating it about the x-axis. And we want to prove that its volume is finite. Okay, so let's start by drawing a picture. What does this thing look like? Well, it starts at 1, it goes off to infinity, not shown here, and we rotate it. We rotate it, and so we get this kind of trumpet shape, something like that. And we want to show that its volume is finite. Okay. Now these questions of figuring out volumes of rotation, they often boil down to what's the best way to slice this shape. And maybe kind of an idea commends itself pretty naturally in this case, because you can see that if you take cross sections that are orthogonal to the x-axis, you get circles. You get these circles, so if I'm at a point x, I get this circle that's of radius 1 over x, because this, of course, is the curve y equals 1 over x. And so if I zoomed into that circle, I would get something that's of radius 1 over x and of thickness, of an infinitesimal thickness, right? Of thickness, well, dx. This is an abuse of notation and also, reason, but it's a useful notation. It's a useful abuse of notation. So what we want to do is we want to add up these disks from 1 to infinity. So the volume, everything falls out of the picture. The volume is therefore the integral from 1 to infinity of the area of one of these disks, so pi over x squared dx. And this is not a tricky integral to figure out. Let's extract the pi, and then we have the integral from 1 to infinity of 1 over x squared dx, which I'll leave the details to you. We're going to end up with pi times, what do we have? We have the limit as, let's say, r approaches infinity, of pi times 1 minus 1 over r. And you can see that as r gets sufficiently big, this thing here gets arbitrarily close to 0. And so we just get pi. This thing has a volume pi, which is finite. So that constitutes the proof, right? We've now proven that its volume is finite. But there are a couple of curiosities. One a little bit unsettling. So first, note that if you figure out the area under the curve 1 over x from 1 to infinity, we did this in the question when we were looking at the divergence of the harmonic series, you get infinity, right? So this area diverges. Maybe even more unsettling, if you look at the surface area of this volume of rotation, which I won't do here, but if you look at the surface area of this volume of rotation, you can in fact show that the surface area is infinite as well. But the volume is finite. So one way of looking at this, I'm not sure who suggested it, maybe Cavalieri. One way of kind of illustrating this seeming paradox is if you filled the horn, if you filled this shape with paint, it would take a finite amount of paint. It would take, in fact, pi volumetric units of paint. But then if you took the paint out and you attempted to paint the outside of the shape, it would take an infinite amount of paint. So you could fill it with a finite amount of paint, but you need to coat it, you need an infinite amount of paint, which is a little bit wacky, but as was said about, I think, one of Euler's formulas, we've proved it, and therefore it's true. It's strange, it's slightly unsettling, but it's definitely true.